Hello, everyone. Welcome to our Succeed with Variable Rate webinar. Thanks for taking the time to join us. My name is Chris Hawkins. I'm the Sales and Communications Manager with CropPro Consulting. I'll be your moderator for this session. Our plan is to be as efficient as possible with the time that you've given us. So we've pre-recorded each of our presentations. They should take about 40 minutes to go through. After that, we'll transition into a live Q&A session where we can answer any questions that you may have. You'll notice each of your microphones have been muted. That way we can stay focused and on track. We certainly do encourage your questions though. So as you think of them, simply press the Q&A button on the bottom of your screen and type your question into the submenu that pops up. I'll be sure to ask your questions on your behalf at the end of the presentations. For those of you not familiar with CropPro Consulting, we are a fully independent agronomy company and we started business in 2003. In 2008, we started doing variable rate using our SWOT maps technology. Today, we have 13 sampling trucks, 6 mapping trucks, and 25 staff throughout the province. Our client base continues to grow because people are starting to realize that we do have the expertise to help them succeed with variable rate. This is validated by the fact that we have over 95% client acre retention rate year after year. So we're proud to share some of that expertise with you today. But before we do that, we're going to ask Carrie DeGoyer to spend time explaining to you what SWOT maps are and why we need them. Carrie DeGoyer is our operations manager and also our senior precision agronomist. She's a professional agrologist and a certified crop advisor. She grew up on a mixed farm just outside of Sheeho and currently makes her home in Melfort, Saskatchewan. She got her university degree in agriculture from the University of Saskatchewan, where she focused on crop science. She joined CropPro in 2014, and part of her role includes providing precision agronomy service to Melfort and northern Saskatchewan. She truly is a proven SWOT maps agronomy expert. She's going to spend about 10 minutes going through what SWOT maps are, and then I'll introduce our main speakers. So without any further delay, please welcome Carrie DeGoyer.
Thank you, Chris, for the introduction. Welcome, everyone. As he said, if you have any questions as we're going along, please put them in the Q&A or wait till we're done and ask them live. So what we're doing is we are mapping soil potential, and the map that we build becomes the starting point for everything that we do next. It's the basis for our soil testing locations and also our fertilizer recommendations. So in essence, what we're doing is we're capturing soil, water, and topography attributes from your field. So take what you're seeing in your field and putting it in a zone map. So taking what we're seeing in your field and putting it in a digital format so that we can manage each area appropriately. So along the bottom, I threw up some example SWOT zone maps overlaid on 3D models of some fields that we work with. And the 3D model is exaggerated just to really highlight and emphasize where the hilltops are versus the depressions. And if you look at our legend, each color on the zone map is its own management zone. So right off the bat, you can see all the high and dry hilltop areas of the field are their own zone. They're managed differently than the rest of the field. And then on the other end of the spectrum, all the water collecting depressions are their own zone as well. So you kind of see where we're going with this. I threw up a field here that was summer followed. And if we still summer followed all our fields, this is very typical of what we would see. You see this hilltop in the foreground and then some hills in the background. They're all drier. They're usually lighter textured soil, definitely lighter colored soil, and also usually a thinner topsoil depth. And then you compare that to as you go into the mid slopes and then these depressions, the depressions are wetter, usually higher organic matter levels, and a thicker topsoil depth. So this is what we would see in our fields, or this is what we do see in our fields. We want to get a map of this because the crop up on this hilltop versus this depression are going to respond to fertilizer differently and yield differently. So we want to make a map of that. How do we do that? We go out and we physically map your fields with our mapping trucks. So I threw up a picture of one of our mapping truck setups. You can see this contraption here. This is a swap box. It's got an EM38 in it, and it's measuring electrical conductivity. And then we've also got this RTK base station set up. And as the truck is driving around the field, it's capturing elevation and topography data. So those two layers put together, the EC layer and the elevation topography layer, they capture a number of things. One of the things they capture is soil texture differences. That's what the EC layer is doing. It's going to delineate where the lighter textured soils are versus the heavier textured soils so that we can manage them separately. It's also going to capture salinity. Not every field has salinity, but if you do have salinity, it's going to really pinpoint where that is so that we can manage that area separately from the rest of the field. A lot of fields actually have light salinity that maybe isn't particularly visible to the naked eye, but the EC layer will capture that as well. And then, of course, for capturing water runs, depressions, and hilltops. So if you think of your own fields as you're combining them, they're not yielding the same corner to corner. You have variability. Now, what causes that variability? It can be 100 different things. It can be man-made. It could be related to insect pressure. It could be related to weed pressure, or it could be related to some fertility-based factors in the field. Things like soil. If you think of your own field, you likely have different topsoil depths and organic matter levels in different areas of the field. If you think of water, where is it dry versus where is it wet? Water's always running somewhere. And this is going to have a big impact on how the crop yields and how the crop is going to respond to fertilizer in those different areas. And then, of course, topography. So threw up another example, SWOT zone map overlaid on a 3D model again. And as I said before, the 3D model is over exaggerated just to really accentuate where the hills and depressions are. But it looks like there's mountains in this field. There's not. But right away, you can see that all these high and dry parts of the field are zone 1 and 2. And then as you go into the mid slopes and the more water collecting areas of the field, you get into the zone 10s. So this map is really capturing the fertility-based variability factors in your field, the different soil types and textures and depths, and where the water is going. One last step before we choose a SWOT zone map is we go out and ground truth it. And what that just means is the agronomists go out and make sure that the map we chose matches the field perfectly. So as the agronomist goes out in this field and they're driving around in a zone 1 area, when they're out in the field, it better be the highest and driest part of the field. On the other end of the spectrum, this is that same example field. This particular field has very high salinity. So when they're ground truthing a field like this, all the very highly saline spots need to be in a zone 10 so that we can manage them completely separately from the rest of the field. Like I said, not all fields have salinity. So if you have a field that doesn't have salinity or fields that don't have salinity, the zone 10 is always the most water collecting area of the field. So it's the areas of the field where water runs to after a big rainstorm. So we've chosen a map. The next step is we go out and soil test it. And our zone maps are 10 zones, but we sample to 5 zones. And this gives us a really, really good idea of what's going on in the field, in all areas of the field. If you compare that to composite soil testing, with composite soil testing, you're collecting soil from the mid-slope areas of the field, putting them in a bag, sending them off to the lab. That's a 1 zone soil sampling procedure. We sample to 5 zones. So with the ones, if the sampling truck is in sampling this field, they go to all the 1 areas, collect cores from there. and put that soil in a bag to go to the lab. And all the soil from this zone should be very similar. They should all be the lightest textured soils in the field, the driest soil in the field. So it makes sense that they're grouped together. And then on the other end of the spectrum, the 5s, this is the most wet, most saline parts of the field. And then we sample 3 zones in between. So these points are all GPS referenced, so we go to them every single year. So we also get a really good picture of what goes on year to year. So how are SWOT maps different? This is a map based on soil properties, and this is really important because we are applying inputs to the soil. So it makes sense that we start with what's going on in the soil. And our SWOT maps can give you an answer to why your crop is yielding the way it is in certain parts of the field. If you were to compare that to making zones from yield or satellite imagery, those don't give you the whys. They just tell you what the crop yielded at that certain point in time. And the big problem with them is that they can group areas together that shouldn't be grouped together. So what I mean by that is you might have a medium yielding hilltop, and you might also have a medium yielding depression. So the satellite image is grouping those 2 areas together. They're both medium yielding, but the soil properties are nothing alike. The crop in those areas are going to respond to fertilizer differently. So that's why we need to use SWOT maps to make a zone map, because we're applying inputs to the soil. It matches the field so that we can manage each area appropriately. And the key point, I guess, is different areas of the field, the crop is going to respond to fertilizer differently. So if we're taking your existing fertilizer budget, you're already spending the money on the fertilizer, we're better able to put that fertilizer where the crop is going to respond more. So where you're going to get the optimum return. So this is my last slide. Not all variable rate is the same. I went through how we map your soil potential and soil test the field. This becomes the basis for what happens next. I didn't go through what happens next. That's where the agronomists in the next section will go through some specific strategies they use in the area. The last point is just saying that everybody's fields and soil test results are different. So what is the value of SWOT maps? We could give specific examples of 10 different ways we can provide value. And those will have a cumulative effect. Some of the strategies, you might put more weight on certain fields than others. But both in the long term and the short term, you will see value to using SWOT maps. And I think the key point is that we have a really high client retention rate year over year. If our clients felt like we weren't providing value to them with our fertilizer recommendations and agronomy recommendations, they could leave us. We don't make anyone sign multi-year contracts or anything like that. So our clients are having success with variable rates because we are starting with a really good base. We're starting with a map that captures soil potential.
Thanks, Carrie. Now it's time to hear from Chantal and Taylor, 2 of our local SWOT Maps agronomy experts. Chantal Bosch is a senior precision agronomist here at CropPro. She's a professional agrologist as well as a certified crop advisor. Chantal comes from and currently lives in the Redvers area, where she's still actively involved in her family's grain farm. Chantal was educated at the University of Saskatchewan, where she received her degree in agriculture, majoring in agronomy, and minoring in ag business. Chantal's got over a dozen years of agronomy experience and joined up with CropPro in the spring of 2020. Taylor Ellis is also a precision agronomist, and she's an articling technical agrologist as well. Taylor comes from the Killdeer area, where she grew up on a mixed cattle and grain farm and currently makes her home in Limerick. Taylor received her diploma in agriculture from the University of Saskatchewan. And Taylor also joined us in the spring of 2020. So these 2 ladies work together to provide precision agronomy services to the southern part of our province. They have a large number of clients throughout this area, with a wide variety of agronomic challenges, often caused by soil variability. So today they're going to show us how they use SWOT technology to help their clients overcome these challenges. They'll be highlighting fields from the Lampman area. So we want to thank Wade Fleck of Railway Enterprises for permitting us to discuss some of his fields. Thank you, Wade. Now, without any further delay, let's hear from Chantal and Taylor.
Thank you, Chris and Carrie, for that. I'll jump right into my portion of the presentation. So at Crop Pro Consulting, we have value propositions, and I've chosen a few that I feel best suit what we're trying to accomplish with SWOT maps in southern Saskatchewan. First off, we have an ROI on applied nutrients. So in our southern Saskatchewan area, there are field-specific soil problems and even area-specific soil problems within those fields where we want to apply nutrients where the crop will respond the most to them. By doing this, we get a better return on the dollar invested in that fertilizer. Secondly, delineate saline areas. We have a lot of water accumulating depressions that are characterized by salinity, and we want to really delineate these saline areas, which SWOT maps do very well. And then the strategy then gets applied to these specific areas where we cut fertilizer back and increase seeding rates. And even crop staging and maturity. These are two strategies where if they're managed well, it really helps throughout the entire growing season. So for example, at fungicide timing and harvest timing. So we can get an even crop, or fungicide timing just gets that much more efficient, as well as if our maturity is all the same at the end of the season, we can more efficiently get harvest accomplished. This can be very critical in challenging fall conditions. And finally, lodging. So by VR applying seed and the right placement of nutrients, we can try to eliminate the lodging issue in fields. Next, there's some agriculture challenges in southern Saskatchewan that I feel SWOT maps really do address. So here I've highlighted or made a square around the area that Taylor and I cover in southern Saskatchewan. And we can really see that we go from a black soil zone to dark brown soil zone to a brown soil zone. And throughout this area from east to west, we also do have a very wide variety of elevation and topography. So our first challenge here is topography. We have a lot of dry eroded knolls with water accumulating depressions, and SWOT maps are very good at identifying these different landscapes and really treating them as their own separate zones. Because we have these water accumulating depressions, it leads me into my next challenge of salinity. So we have a lot of bathtub-ring salinity because of these water accumulating depressions. And like I mentioned on the previous slide, SWOT maps are very good at identifying these zones so that we are able to treat them separately. And finally, limited growing season precipitation. Because we're limited by in-season precipitation on some years, we just have to make sure that our SWOT maps and our nutrient prescriptions really match what we want out of the growing season. The next few slides, I've done a case study here where I've chosen a field of Wade's at Lampman, Saskatchewan that I feel really represents a lot of fields that we see across southern Saskatchewan. So right away, you'll notice all of these sloughs or water accumulating depressions, which is very common in many areas of southern Saskatchewan. And then I've circled the high elevation as well as the low elevation part of these fields. This is the topography map. So the blue and purple areas being the hills and the red areas being the depressions. And this is a very important layer because of our rolly countryside, or our pothole country, like we like to call ourselves. We really want to address these areas separately. So we want to treat the depressions in the high and the low elevation parts of the field the same, and we want to treat the knolls in these same lower and high elevation parts of the field the same. And this topography map just really helps us do this. Next, we have the electrical conductivity, or EC layer. This is also a very important layer in southern Saskatchewan. Because of these water accumulating depressions and that bathtub-ring salinity, we really want to identify the saline areas of the field, which would be these blue and purple areas on this map, and treat them all as the same zone. So this layer is very important because it helps us do that. It helps us pick out these areas, treat them all the same way, and then we want to make sure we're treating these non-saline areas differently. And finally, we have the SWOT map. So this is the final version of the map that we will use for this field for our VR, fertilizer, and seed applications. And you can notice here that all of these knolls are this red color and all are going to be treated the same as the zone 1, 2. And then you can see that the depressions or the saline areas, these dark green areas, are the zone 10s, and they will all be treated the same. So this map really represents the overall field and what is happening within this field. Next here we have the SWAT map with our soil sampling points marked. And then this is a picture I took in the fall of 2020 soil sampling of the soil taken from a field. So the different buckets being the different zones. So the first bucket here being zone 1, 2, second bucket being zone 3, 4, so on and so forth. And then finally this last bucket here is zone 9, 10. And you can see the difference in the soil as you go from a zone 1 to a zone 10. And this is a very common trend that we see across southern Saskatchewan, and just the eroded knoll to that water accumulating depression. So your zone 1, 2 soils are going to be characterized by low mineralization, they're water shedding, they're likely depleted of nutrients, and they are lighter textured soils. So would you say this soil is high or low fertilizer response soil? Well, it's actually a high fertilizer response soil. And it's a high response soil because we're actually going to need more fertilizer in this zone to get our yield goal at the end of the day, just because this soil has all of these characteristics. So because it's depleted of nutrients, it has low mineralization potential, it needs more fertilizer to get the yield goal that we want achieved. If we move to the opposite end here, so our zone 7, 8 soils, these have greater mineralization, they're water accumulating, they have an excess amount of nutrients, and they have a greater accumulation of A horizon. So would you say these soils are high or low fertilizer response? Well, these soils are actually a low fertilizer response soil, and for the opposite reasons of your zone 1, 2. So because they have greater mineralization, they're water accumulating, they're going to actually release more nutrients themselves throughout the growing season. So they likely also have higher organic matter, and all these things lead to just more mineralization or more release of nutrients through the growing season. They're also likely going to utilize the fertilizer applied better than a zone 1, 2 soil will. I've left out zone 9, 10 from this, but it'll have a lot of the same characteristics as a zone 7, 8 soil. However, its biggest limiting factor in southern Saskatchewan is going to be salinity. And these soils likely have a very high saline content, which is the reason why they have to be treated differently. This is the fertilizer responsiveness graph that we use at CropPro, and it really breaks down our zones and really gives a good description for the fertilizer response probability from these zones as well as their yield potential. So if we look at a zone 1 eroded knoll that has a lower yield potential but a high fertilizer response, so like I said, we'll have to put more fertilizer in our zone 1 to get that lower yield potential. And then we look at the opposite end of the spectrum, so our zone 10 saline depression, it has a low yield potential and a low fertilizer response. So we actually won't be putting that much fertilizer, if any, in these areas. Then if we move up a little bit to our zone 8 toe slope, we have an average yield potential and a medium fertilizer response. And then if we go to our best areas of the field in our SWAT maps, our zone 4, 5, these areas have a high yield potential and a high fertilizer response. So these are areas in the field that are gonna really get the max fertilizer rates because they have the highest fertilizer response and the highest yield potential. The next few slides, I'm going to go over the 2020 fall soil sampling results for that case study field at Alatman. And what I've done here is I've put the soil sample results to the area that they were soil sampled from. So nitrogen at 12 pounds, organic matter at 2%, and salinity of 0.23. These results come from our zone 1, 2. So this eroded knoll is what the soil sample results were for this field. If we move to zone 5-6, the nitrogen is at 15 pounds, the organic matter is 2.6%, and salinity is 0.29. And then if we move to our water accumulating depression, zone 9-10, we see nitrogen at 123 pounds, organic matter at 3.2%, and salinity at 4.23. These are very common trends we see across fields sampled in southern Saskatchewan, where residual nitrogen on an eroded knoll is usually the lowest in the field, and then it gradually increases as we move through the zones. Here in zone 9-10, that's quite high residual nitrogen, likely based on the fact that we sampled areas in 2020 that we likely couldn't get to in 2019, especially in those water accumulating depressions. And so hopefully we're able to grow a crop there in 2021 and really utilize that available nitrogen. Organic matter trend, also a very typical trend we see, lower organic matter on our eroded zone 1-2, slowly increasing, and then the highest here in this water accumulating depression. And then salinity also, this is also a typical trend where we like to see low saline soils, so good crop growing conditions with this low salinity levels in zones 1-6. And then our zone 9-10, really that salinity number skyrockets. So when we see anything over 3, that's a very saline soil for us. And so soil at 4.23, it'll be definitely limited by that salinity number. We also have to look at this mineralization potential of the soil. And so in this field, it's going to have the highest mineralization potential in our zone 8, and that mineralization potential will decrease as we get to our zone 1. So like I'd mentioned earlier, mineralization is tied to this organic matter number and just to overall soil quality. So it's highest in these depressions or the toe slopes because of higher organic matter, more water accumulating, and just a nicer, thicker A horizon. And so, as I had mentioned earlier also, mineralization is just that soil's potential to mineralize and create or release nutrients through the growing season. So is increasing nitrogen rates always the benefit? This here is a picture of a flat rated wheat field. And we can see off in the distance our zone 1-2s, where the same amount of nitrogen would have been applied than our zone 7, 8, 9, 10 here in these depressions. As we move through these zones, we can see this trend where we're starting to have crop lodged. This goes back to my previous slide, where this area of the field likely has more mineralization, it has more moisture, and it also has likely a higher amount of excess nutrients. For this reason, we wouldn't have to apply the same amount of nitrogen here in our zones 7 to 9 as our zones 1, 2, 3, 4, even 5. So really, we're not gaining much with yield with this high nitrogen rate throughout the entire field. At the end of the day, it's causing delayed harvest issues with lodging and poor dry down, which is going to lead to a poor looking sample and a loss of grade, higher moisture content grade, and a chance of a risk of frost affecting this crop because of the slow maturity here at the end of the growing season. Next, we have phosphate, and with the phosphate numbers, I've also put the pH values. So on our eroded knoll of zone 1-2, we have a phosphate number of 6 parts per million and a pH of 7.5. Zone 5-6, we have a phosphate number of 3 parts per million and a pH of 7.1. And in our zone 9-10, we have a phosphate number of 6 parts per million and pH of 7.6. So this field, which is also quite common for southern Saskatchewan, are these really low phosphate values. We're seeing this more and more, very low phosphate residual numbers. Anything below 15 parts per million for us is considered very low. Typically, because southern Saskatchewan is characterized by more basic soils, we can see tie-up happening of our phosphate when this pH gets closer to 8 and even over 8. However, this field is actually fairly neutral to not too concerning to be basic. So I'm not as concerned about the tie-up effect here, but I am concerned about these low residual phosphate values, which we would address in our fertilizer recommendations. Next, we have our potassium and chloride. So I've put these two together because they are somewhat linked, but only for the reason that we would address both issues by applying potash. So potassium here on this eroded zone 1-2 is 424 parts per million, and chloride is 4 pounds. Potassium in the zone 5-6 is 532 parts per million, and chloride is 12 pounds. And then in our depression here, zone 9-10, we see 456 parts per million of potassium and 91 pounds of chloride. It's very common in southern Saskatchewan to see very high potassium numbers, so that's not usually the limiting factor. However, sometimes our chloride values can be, and we consider a low chloride number to be anything less than 10 pounds. And so on this eroded knoll, zone 1-2, I'm actually slightly concerned about this chloride number, and depending on the crop they were going to grow, it would be something that we would look at possibly addressing. Next, we have our sulfur fertilizer values. And in this eroded zone 1-2, we have 19 pounds of sulfur. In our zone 5-6, we see 160 pounds. And in our zone 9-10, we also see 160 pounds. These zones here at 160 pounds it's quite enough sulfur. The lab's max out testing rate is actually 160 pounds. So there is adequate supply of sulfur here. However, in our eroded zone 1-2 at 19 pounds, it's actually quite concerning because it is considered a low testing level. And this is actually quite typical to see across southern Saskatchewan. There's less mineralization happening here. Sulfur is very mobile in the soil, so it could leach to these lower zones. So it is something we definitely want to address, especially if we're looking at growing canola on this field. This is a zero sulfur trial that we did at our PARS research site in Nacum, and it just really drives home the message that we had shown in the previous slide. So in this field, they put a zero sulfur strip throughout the entire field that covered all the zones, so from zone 1 to zone 10, and then watched the changes throughout the growing season. Here, these pictures were taken when the crop was just about ready to bolt. And we can really see the differences between the zones. So in our eroded knoll, zone 1-2, these plants here look stunted. They have cupping of the leaves. The outer leaf margins have chlorosis, and the plant is definitely affected by a sulfur deficiency, which would be common to see because it's likely a lower residual amount of sulfur on these soils. There's less mineralization, and there is no sulfur applied. However, if we move to the lower zones, so zone 7 to 9, also no sulfur applied. However, these plants are nice, healthy, and green. They have large green leaves. There's no yellowing or chlorosis. And so it just goes to show that these plants were actually able to utilize the sulfur that was in the soil because it likely had a high residual amount of sulfur, greater mineralization. And so overall, we didn't need that sulfur in these zones. And finally, the prescription that we would write for that case study field at Latman. So this is what our variable rate prescriptions look like at CropPro. We've got our SWOT map here in the top right corner. We have our yield goal by zone, and then our average yield for the entire field based on what the farmer would want. And then the different layers are the different tanks and the different products that we'll be applying to this field. So we have our urea for our nitrogen, our S15 for our phosphate source, and then our canola seed. Down below, we have the breakdown by field. So the percentage of the field that we find in each of the zones. We have our soil sampling results, so the last 3 years of nitrogen results, and then all the other nutrients and the results from the last time they were tested. The trend for urea here, and it's kind of the same strategy we would use across southeastern Saskatchewan. The strategy might change slightly if we move into southwestern Saskatchewan. We're putting on quite a bit of nitrogen in these upper zones because they're a high fertilizer response zone, even though they have a lower yield potential. Then we're going to increase that nitrogen to our zone 5, 6, and then start to decrease again as we move through the lower zones. All the way to the zone 9, 10, where we're really decreasing our amount of urea applied and then backing it right off. So if the equipment and the control of that equipment is able to, we will put a 0 rate in this zone 10 because of the high residual amount of nitrogen and that high salinity number. If we look at phosphate, we don't change as drastically our phosphate values just because that field is quite limited by phosphate. So we don't want to be shortchanging it or cutting rates back too significantly, but we will still cut back quite a bit in zone 9, 10s because of the high salinity and just that lower yield potential. And then finally seed. So we're increasing seed in our lower zones because they usually have a high mortality, especially here in this high saline soils of zone 9, 10. We'll increase to try to get plants to grow so that we can suck up those salts or lower that water table and then utilize those nutrients that are in those areas. This isn't always the strategy we use. If the salinity is too high and we feel like there's no crop that has a chance in those areas at all, we will back this number right off. Next, Taylor is going to talk more on the strategy here of this VR seed.
Thanks, Chantel. With variable rate seed, the goal with it is to even out maturity across the field by ensuring we achieve target plant stands across all areas of the field. An even plant stand reduces excess branching and tillering, and the largest influence on plant stands after seeding is seed mortality. Factors that influence this include insect pressure, too much or not enough moisture, salinity, and variation in the microclimate around the soil surface. What I mean by that is wind damage on the knolls and frost damage in the depressions. If you think of all these factors and consider which areas of the field will have the higher mortality, it is going to be your zones 1 and 2s, the hilltops, and those zones 9 and 10s, water collecting saline depressions. The seed applied in these 2 areas of the field are going to have a harder time establishing. So the strategy with the VR is to apply more seed in areas with higher mortality pressure. There are some other benefits to VR seed as they pertain to ensuring an adequate plant stands across the entire field. We can ensure that the crop remains competitive in marginal areas and reduce weed pressure and infestation. When we achieve even maturity across the field, fungicide and pre-harvest application can be much easier to time. So I've included a seeding rate prescription from one of Wade's fields and then the corresponding plant stand count report we did later that season to show you what we were doing with the VR seed. If you have a look to the left at the VR prescription and focus on that Durham column, each column of the VR report is a tank and a drill. You can see that the average we applied was 135 pounds per acre of seed. This was determined using the seed lot germ and TKW information. Every seed lot will be different, but with this one, we needed to apply 135 pounds per acre of seed to achieve the target plant stands. But when you have a look at what we did within each zone, you can see that those zones 1 and 2, the high and dry areas, we applied 145 and 140 pounds per acre of seed. Then once we start moving into those mid-slope areas, those zones 3 to 6, we actually start cutting back the seeding rate to 130 pounds per acre. And then we get into those water collecting and saline areas of the field, and we actually crank the seeding rate back up again. So this was applied in the spring, and then a couple months later, we went back out and did plant stand counts on this field. We do plant stand counts on every farm every year, and we've done thousands of these. These serve as a report card to see how we did and if the strategies we use on this field were correct. So on the right, if you have a look at the plant stand report, you can see on those zones 1 and 2 areas, we got 27 plants per square foot. And same with those mid-slope areas, we also got 27 plants per square foot. And when you have a look at those zones 9 and 10, we hit the 21 plants per square foot. We were targeting 30 plants per square foot. And overall, this field had a pretty good plant stand count across all zones. Those zone 10s had that high salinity, so we're just happy that something is growing here. If you back calculate the numbers, remember that we applied more seed on those hilltops and saline depressions, but it's not like we're ending up with more plants there. The mortality is just higher here, so we end up with the target. We had 25% mortality on those hilltops. The mid-slopes, we had 15% mortality. And of course, these highly saline depressions had really high mortality. So we just want something to get established here to compete with that kochia and use up any excess water. Evening out the field and its crop staging has its benefits to better control a fungicide spray like Fusarium and Sclerotinia. Now, if we pick on Fusarium, we all know that that window for Fusarium fungicide application is so narrow. So we want to ensure majority of the crop is coming in at the same stage. Having even maturity will help make the application timing decision a lot easier. I've included some pictures from my colleague up in Yorkton. She took these from her farm, and these are two separate fields, only 1 mile apart. One field has variable rate seed and fertilizer using the swap maps, and the other one is a flat rate. So if you compare the two fields and the staging within those fields, you can see that the VR field in the zone 2s, which are the shoulder slopes, the heads are coming out of the boot. And same thing with those zone 8 depressions. Both areas of the field have the same stage and make that spray decision a lot easier to make. Comparing to the field that only had flat rate fertilizer and seed, we can see what is likely a zone 2, the heads are coming out of the boot, but what is likely a zone 8, the depressions, the heads aren't even out of the boot yet. This field is much more uneven, and it will make that spray decision timing a lot harder to make. By ensuring majority of the field is coming out at the correct stage all at the same time, you will have a better success with your fungicide application, which in the case of Fusarium means you will have a better grade and more profit. Now, if we fast forward to later in the season, even maturity makes for a more efficient harvest. So we go out and do a second on-farm visit with all of our clients right around that pre-harvest timing to get a good picture of how the crop looked and how even the fields were by the end of the season. Does this field have even maturity? Was there any logic? Is there anything we can learn and improve or tweak for next year? It's important to note that we do a couple on-farm visits throughout the year where the goal is to always double check that our strategies we are using on the farm are working and still apply, or are there things that need to be adjusted? Thanks. Back to Chantel.
Thank you, Taylor. Finally, I'm just going to wrap up with why swap maps would be a fit on your farm for your fields in southern Saskatchewan, and also some other application and uses for swap maps. So first off, why swap maps? Well, we delineate management zones very well, and these management zones combine water-driven yield potential and nutrient responsiveness. So they're just very important characteristics to delineate and manage separately. And at the end of the day, they're going to give you your best return on investment and your best yield potential for your fields. Secondly, we model water flow and accumulation. These two factors are major causes of soil variability and are just going to be very good things to map to show you the best potential of your field. And finally, the third point is our maps are based on stable soil characteristics. So the maps are built on soil characteristics that you've had in the past. The characteristics have been there since the glaciers retreated hundreds of millions of years ago, and they're going to be there for hundreds of years to come. So we're mapping the stable part of that field. Therefore, very little is going to impact our maps, and they are going to be good for many years to come. The only thing that would drastically make a map change would be if you were going to do major drainage work or move a pile of water. There's other swap maps applications. So for salinity and drainage, so once we've delineated saline areas and mapped the field, there's some other uses that come out of these layers. So in this picture here, we've actually layered the flow paths of water in this field, so the main ones and the secondary ones. And this is a layer that's available to the farmer or to you at no additional cost. And it's just a very good indication or a very good map to show you the way the water moves through the soil or through the field. And then this picture here is actually a drainage map. And so with the data that we accumulate while mapping, we're able to make drainage plans if that is something that the farmer wants. We're able to maximize genetic potential. So through our VR seed rates and putting the right seed rates in the right areas, we maximize that dollar invested in the seed. But the other thing that we're starting to do is actually put multiple varieties on the same field. So if you had a canola field and there is large variability in elevation topography, and you want to put a short and a long season variety on that same field, it is something that would be very easily done and would actually even out that maturity even more. We can make VR pesticide application maps. So a pre-seed soil herbicide map, if you were trying to apply a pre-seed product that was based on certain soil characteristics such as soil texture or organic matter, we could very easily use our SWOT maps to make a prescription to say apply a certain product in zones 7 to 10 to combat kochia or something like that. We can make VR insecticide maps, and we can also do a VR fungicide application map. And finally, environmental stewardship. So all the above factors that we've discussed today play into this, but it's hard to put a monetary value to it. But by managing excessive water, reducing over-application of nutrients and nutrient loss, or even reducing pesticide use, these are all things we strive to for long-term productivity and long-term sustainability. Thank you.
Okay, thanks Chantal and Taylor as well. You did a fantastic job of presenting that information. We appreciate that. So folks, that brings us to the end of our formal portion of our presentation. I'm hoping that you may have some questions, and by all means, please jot them into the Q&A session at the bottom of your screen. Yeah, Q&A button. But while you're thinking of some questions, I'll just go through our $1,000 mapping credit. We have an incentive that we're offering to those of you who are on this webinar today. It's a very straightforward incentive. Simply map 160 acres this spring and we'll cover the first $1,000 of the cost on that field. It is important though that if you want to take advantage of this, that you jot your name and your phone number into the chat box, and you can direct it to the panelists and it'll only go to us, and then we can get in contact with you to set things up. Now, those of you on the call that are existing clients already, you will have seen in your advertisements, whether it be through flyer or email or whatever, that if you refer someone to this webinar and they become a new client, then you also are eligible for the $1,000 credit when you do new mapping this spring. So again, it's 160 acres and we'll cover the first $1,000 of that. So just maybe when you're putting your name and information in the chat box, make sure that you tell us who you referred that's brand new to Crop Pro. And if you have any questions about any of this, certainly give me a call or any of the presenters as well. Our contact information is on the screen. And I'm not sure if Coral, you're going to leave that up for a bit, and you can do that. And then people can jot down the information. Thanks, Coral, for running this webinar, by the way. We didn't introduce Coral Blakey at the start of the presentation, but she's kind of the hardworking person behind all this to make it happen. So we really appreciate her efforts, and I want to give a shout out to Coral. She's our marketing manager here at Crop Pro. So with that, now we have time to ask and answer some questions. The first one is from Joe, and he's asking, how does the cost break up per year? Well, break down per year. I can answer that question for you. First off, when you go to croppro.ca, you should see our price list there. So as I'm explaining it to you, if you don't follow along completely, you can certainly refer back to that. But simply, if you're under 1,000 acres, it's $12.25 for the first year. And then that year covers all of your mapping, it covers all of your sampling, it covers all the VR visits, and the whole program is $12.25. However, every year after that, the price drops to $4.60 because once the map is made, it's made. We don't have to make it a second time. And that's a big portion of the cost, is making that map. So every year after that, $4.60 an acre, and we still do the soil sampling, we still write the prescriptions, we still do the VR visits. It's a very intensive program year after year, but it becomes very, very affordable once the mapping is done. If you want to discuss that further, Joe, reach out to me directly and I can give you more information on that. So we do have another question, and this one is for, I'll send it to Taylor. How do you get or calculate your average seeding rates for a field?
Yeah, to get the average seeding rate, we take into consideration the seed lot germ and the TKW, so how big the seed is. And we'll have a target plant stand that we want to achieve. So we'll take the target, the seed germ, the TKW, and we put that into the seeding rate calculator to get the average. Every seed lot will be different. So it's a case-by-case basis. Of course, the bigger the seed, the higher the seeding rate will have to be to achieve the same target plant stand. And then, as I mentioned, within each zone, we'll vary the seed rate based on the different mortalities in a given field.
Okay, very good. I see another question here from Kurt. He's asking, are soil zone samples taken every year? And I guess I did answer that one a little bit earlier when I was talking about pricing. Maybe what I'll do though, Chantal, is I'll ask you to explain the difference between sampling in year 1 versus sampling in years 2 and beyond, and how we approach that.
Sure. So on year 1 of sampling, so if we have a brand new field that we just mapped in ground truth, we'll sample the five zones like we'd mentioned earlier, but we'll do a full default sample is what we call it. So it'll be your full macros and micros, as well as organic matter and everything, pH. And then year 2 and 3, then it defaults to, typically we'll just sample the nitrogen and sulfur for the following years. And it's always a 0 to 8 inch sampling depth. But if the farmer wants to add phos or potash or anything else in the following years, that's up to him. But typically we'll just then sample the nitrogen and sulfur in the following years.
Very good. Yeah, and if you do choose to add any additional nutrients to your test in the recurring years, it's not expensive. Like it's $15 per field per nutrient. So it's not an expensive thing because we're doing the labor anyway. It's just that we don't do it unless you ask us to do it. Nitrogen and sulfur are the ones that change the most. So, okay, another question's come up here. It says, I've seen a lot of information about how the ROI is not necessarily cut and dried, and it's hard to define. Do you have any data comparing the outcome of a VR versus a non-VR field and providing cost-benefit analysis? Maybe Carrie, do you want to take a hold of that one?
Yeah, I guess I just kind of briefly touched on it in my intro, and I do agree that calculating an ROI it's not really cut and dry, but over the long term, it should be more cut and dry. And when I mentioned how every field and soil test result is different, that really plays into what is the ROI. But when Chantal showed that field where we put no sulfur on a strip across that field by NACM, that was by NACM, but we could do this anywhere. And how you could see on the hilltops, the sulfur deficiency on those plants was just astronomical. So the ROI on that, putting more sulfur on a area of the field that is going to respond more is, I guess, one way to look at it. How do you measure it? If we would have taken that to yield, for example, and seen what that canola on the hilltop would have yielded without sulfur, it would have been pretty low. So if you would have added sulfur to it, the return is a lot higher. So I don't know if I really answered the question. Every field is different. So
yeah, yeah, for sure. We are doing a lot of work with yield analysis though. We can offer yield maps to our clients that have SWOT maps, and it's kind of a new thing that we're bringing out, and it's looking very promising. Yield is always, you always want to take it with a grain of salt because yield can be impacted by so many more things than just fertility. But we're starting to get to the point where we can show you yield by zone. So that'll be coming out here in the near future. Another question that we have is from Wayne and Bonnie. Thanks for the presentations. Chantal, have you found any changes in pH levels with different fertilizer applications? I think ammonium sulfate applications are lowering the pH level, but that is only a hunch.
To say that a fertilizer application is actually affecting your pH level, like long term, probably not so much. There is like a temporary pH adjustment when that soil first hits, or that fertilizer first hits the soil. But to say it affects overall long-term effect of your pH, probably not so much. There's definitely other things that we've heard of guys doing that would more likely impact the pH. Let's say if you had an acidic soil and you were liming or something like that, those would likely more affect your pH than typical fertilizer practices.
I think I'll just add to that, the buffering capacity of your soil would have an impact on it. So if you have heavy clay, high organic matter soils, the change in pH over time probably isn't very much, but if you have sandier, lighter textured soils and you're applying fertilizer long-term, there is probably acidification happening in the long term, but it does depend on the soil in that case too.
Okay, very good. Okay, I have another question here. This one is for you, Chantal. You mentioned that hilltops are a high fertilizer response, but a low yield potential. Why would we put a high rate of fertilizer up there? Are there times when there does not, are there times where that does not make sense and maybe isn't the best strategy?
Yeah, I should have expanded on that a little bit more. So it's definitely area specific within southern Saskatchewan. So we see a trend kind of in southeastern Saskatchewan where we do typically get a little bit more moisture. We are more of a black soil zone where our knolls probably aren't as dry, don't typically get as dried out as if, say, if we move further into southwestern Saskatchewan. So definitely that is a method that we use, and it gets tweaked depending on the area that we're working in.
Mm-hmm. Okay, good job. So now another question from Wade. Do you think EC changes enough over a number of years to warrant remapping after extremely wet or dry cycles? Have you looked at decades-long trends on fields that have been mapped for 20 years or so? Not sure who the best one is to answer this one. Maybe I might throw it at Carrie because she's got the most experience with older maps. So why don't you take that one, Carrie?
Yeah, so I work closer to NACOM, where we've had clients since we started in 2008, and over time we've tested this out and remapped some of our very first fields we've done. And with EC, it's all relative. So in relative terms, that doesn't change. The levels might change, like the levels of salinity might change, and that's where the soil tests would pick that up. But the saline area of your field is always going to be the most saline area of your field. So the map itself doesn't change over time. The only exception to that maybe would be if someone has installed tile drainage and over time the salts are leaching out of the soil and going through the tile. But even then, it's probably more so just the soil tests will show that the salts have gone down, but where the person put the tile will still now be the most water collecting area of the field. So it still will be the zone 10.
Okay, very good. So here's another question. From JR 492. If I plan to use a lower rate of nitrogen in spring and then bump it up later in the growing season, I'm assuming you would work with the farmer to account for that when seeding. Chantal?
So I don't think like, as in we're going to top dress in season? Is that what?
Yeah, let's see, I'll read it again here just to make sure I understand it. If I plan to use a lower rate of nitrogen in spring and then bump it up later in the growing season, yeah, I would presume that, yeah, top dress for sure. There's the clarification.
Okay. Yeah. So yeah, if that we're even coming into that situation kind of with fall or spring of 2021, where we're kind of, a lot of southern Saskatchewan is heading into some drier soil conditions for seeding. And we're talking about just nitrogen application rates. And if we do want to cut back a little bit going into spring, and the option then would be, if we do get the moisture throughout the growing season, we could top dress. And definitely if the equipment is capable, or say you had soil moisture probes or anything like that, and you wanted to do a VR top dress plan, that's definitely something that we would work with. I believe there are additional costs for that, but I'll default that one to Chris.
Yeah, the top dressing program is actually very inexpensive. When you already have a SWOT map and you've already used a prescription in the spring, the first prescription's covered in the total cost that we discussed earlier in the question session. But any top dressing that you do is just $50 a field. So regardless how big your field is, it's $50 because we already have the map. We've already done the ground truthing where it's just a matter of making prescriptions. So it's very, very inexpensive. If we have to start incorporating satellite imagery into the decisions, maybe if we're considering fungicide or if we're considering insecticide, then there can be an additional cost to that. It ends up being, let me just check my sheets here. Yeah, 50 cents an acre. So still not expensive, but if we have to incorporate satellite, it does add some extra cost. So I don't think I see any more questions. Do any of you see any that I might have missed in the chat? Or, oh, here's one. How big are zone pixels? Well, we use a 10-meter resolution. Is that not correct? Well, that's for top. Go ahead, Carrie. You're about to answer that one. I'm thinking.
Sorry, can you repeat what the? I think I heard
how
the
big
question.
How big are the zone pixels? And I'm not exactly sure what the right answer is to that, to be honest. But
I'm not
our
sure.
resolution is real high, but I'd have to confirm that. Can I get you? This is Joe. Can I get back to you on that, Joe? I don't exactly know the answer, and I don't want to guess. So I'll make sure that we can reconnect with you and get you that answer. But zones in general, they vary in size on every given field, right? Like we use 10 zones on every field, and regardless of the size of the field. So you can have zones that are fairly large and zones that are fairly small. It just depends on the circumstances of the field. And when you actually get your prescription report, it'll give you the breakdown of how many acres are represented in each one of those zones. But we'll reconnect, Joe. I think you left your phone number for me in the chat. That's good. I can give you a shout. Okay, and if there are any other questions that people have that maybe they're a little uncomfortable sharing on a public forum like this, again, throw your name and your question in the chat, and or just connect with us directly. Coral, can I ask you to put our contact information back up on the screen? And then if somebody wants to screenshot it or just write down our numbers, they can do that, or our emails or whatever they choose. But I think that brings a close to our presentation and to our webinar. We're 3 minutes past 11. I'd say we did a real good job at staying on time. And I thank each of the presenters. You did an awesome job. And thank you again, Coral. And especially thank you to all of you who joined us. We appreciate you giving us your time. And I'll look forward to connecting with those of you who have asked us to reach out. And I'll wish you all the best at seeding time coming up. So we'll shut her down, Coral. Thank you.